Okay, so what I have here is y equals x squared minus 12x plus 7. And what we're going to do is we're going to solve this by completing the square. So as we talked about completing the square, what we want to do is we pretty much want to take it from our standard form to our vertex form. So therefore, we can use our inverse operations to be able to solve this quadratic. So the first thing we want to do is when solving, we want to be able to find the values of x. They're going to make this equation true when our output or our y is going to be equal to 0. And previously what we've done is we've worked on factoring. But a lot of times completing the square helps us out is when we cannot factor it and we don't know the quadratic formula or worried about that, we can use completing the square. So looking at this, the main important thing is we want to transform this equation into this vertex form. And the reason why we want to transform it that way is therefore we can have a binomial squared, because now you can see that here I have an x squared and an x. Here I only have my x, even though it's being squared, but it's one x that I can now isolate by using my inverse operations. So what we need to do, our first thing is we need to create this. We need to make sure that our a is 1. So I look over here and I see I have an a is 1, which is good. Then the next thing I'm going to do is I'm going to put parentheses around here. And what I'm going to want to do to create this binomial squared, I need to create a perfect squared trinomial. So therefore, I have a quadratic term, a linear term. I need to find a constant that's going to make this a perfect square trinomial, because 7 does not make it a perfect square trinomial. So what I'm going to do is I'm going to create that number. And to do that, we're going to take b divided by 2 and square it. So in this case, my b is negative 12. So I take negative 12 divided by 2 and square it. Well, negative 12 divided by 2 equals a negative 6 squared, which equals a positive 36. So therefore, this number is going to be, if I add this inside this parenthesis, that's what's going to make my perfect square trinomial. Now, when we take an equation and we add something to it, we need to make sure that we add to the other side, or we could add and subtract to the same side. So rather than, I want to find the values when they're equal to 0, so I'm not going to, actually, let's go and do that for both of them, for one of these. So if I add 36 on the right side, remember it's an equation, you have to add 36 on the left side. So rather than equaling 0, it's not going to equal positive 36, but I don't need to write the plus sign in front. All right, so remember, whatever you do on one side, you have to do it on the other, right? When solving equations, that was one thing we went over. And then there's still a plus 7 over here. All right, so now we've created a perfect square trinomial, which we now know can factor down to a binomial squared. And you think about this, if we go back to trying to factor this, what two numbers multiply to give you 36, but then add to give you negative 12? Well, we figure out those two factors are going to be x minus 6 times x minus 6. But rather than writing it as x minus 6 times x minus 6, we're going to want to write this as x minus 6 squared. So therefore, I write 36 equals x minus 6 squared plus 7. Now I need to isolate this variable. So now I'm going to use my inverse operations to get the x by itself. So the first thing I do is subtract the 7. So therefore, I have 29 equals x minus 6 squared. Now, continue my inverse operations, I need to undo the square root. So to undo the squaring, I need to take the square root of both sides. And then the square root of 29, I cannot simplify, but that's OK. That just means now I'm going to have an irrational number or root or solution for my equation. So I have the square root of 29. But remember, since I introduced the square root, I need to make sure I include the positive and the negative value, equals x minus 6. And then I add 6 to the other side. And therefore, my final solution is going to be x equals 6 plus or minus the square root of 29. And we always want to see, can we simplify the square root of 29? And unfortunately, square root of 29 is prime, so therefore, I'm not going to be able to simplify it any further. And my final answer is going to have two solutions, 6 plus the square root of 29 and 6 minus the square root of 29. So there you go, ladies and gentlemen. That's how you complete the square. Thanks.